In this one, we're just going to find the partial fraction decomposition, the PFD. No integrals in this example. All right, so the first thing to do is to notice that this is equal to 1 over x times x squared plus 1. So factor the denominator. First step, factor the denominator. And we're going to write this as, so the setup, right, is 1x x squared plus 1 equals a over x plus bx plus c over x squared plus 1. All right, now I know that probably looks awfully odd to many of you. And the way I want to explain it is let's look at this piece right here. So the degree of a polynomial is the highest power of x. So the degree of x, the degree equals 1. And where a is going to be a number, so we'll say the degree equals 0. Because you could think of this as, because you could think of a as a times x to the 0. Remember, x to the 0 is 1. So a times x to the 0 is a times 1, which is just a. And so in this case, the highest power of x is 0. And so the idea is you always want the thing on top to be 1 degree less than the thing on the bottom. You want the numerator to be 1 degree less than the denominator. So in this piece here, a over x, the degree of the denominator is 1. 1 less than 1 is 0. So that's why the degree of the top is 0. In a similar way, now look at this second piece over here. Right, the degree of, actually, let's not do that. Let's just say this thing here has degree 2, right? And so we want the top, bx plus c, to be the most general possible form, but one of a polynomial that's 1 degree less. So the bottom, the denominator, is degree equals 2. So then the numerator is degree 1. And we want to have the most general possible form for the numerator. The most general possible degree 1 polynomial, which is some number b times x plus some number. That's c. So that's bx plus c. So that's how that goes there. All right, so then now everything else is the same. Multiply both sides by the denominator here, x squared plus 1. Multiply this side by x squared plus 1. Those cancel. We get 1 is equal to a over x times x and we're going to multiply by x squared plus 1. That cancels. That cancels. We get 1 equals a x squared plus 1 plus bx plus c times x. So now distributing this a through to the x squared and the 1, we get 1 is equal to ax squared plus a. Distributing this x to each of those pieces, we get bx squared plus cx. And now collecting all the pieces with x squareds together, we have 1 equals ax squared plus bx squared. And then all the things with just an x, there's only one of them in this case, plus cx. And all the things with no x's, there's only one of them in this case. Now using the distributive property in reverse, we have a plus b x squared plus cx plus a. And now we write the left-hand side here as 0 times x squared plus 0 times x plus 1. And notice that is equal to 1. Just 0 plus 0 plus 1, that's just 1. And now remembering that two polynomials are equal when they, if and only if they have the same coefficients, we know that a plus b has to be 0, that 0 has to be equal to c, and that a has to be equal to 1. And so let's write that out. We have a plus b equals 0, c equals 0, a equals 1. So if a is equal to 1, b equals negative 1. And so now we've found that one over x squared plus 1 is equal to a over x, a was 1, plus bx plus c, b is negative 1, so we've got negative 1x plus 0 all over x squared plus 1. Simplifying the numerator there a little bit, we can write this as negative x. And now if we want to check our work, we can see, does this side actually, when we do the math, when we do this addition, does it actually equal this side? So let's do that. So 1 over x plus negative x over x squared plus 1. This is going to be x squared plus 1 minus x squared all over x squared plus 1. We see those will cancel, and it checks out. And just to emphasize that, remember, we factored out the x to get that there. I'm going to write this denominator like this. You'll see why I did that in the next video.